All right, Spacers, welcome back to another episode of the Space Revolution. My name is Rick Tumlinson, and you are listening to iRock Space Radio. We're a part of the iHeart Radio Network, and we're very happy to be that. Hey, we have a great show tonight. We're going to talk about some cool stuff. I don't know if you've ever heard of the concept of space elevators, but oh, yeah, we're going to talk about that. So, as we are going through these shows, I want to inform you that we're going to have a wide range of guests. If you've been listening, you've heard that. And these are people quite often who have been out in what I call the trenches, and people that have been really working hard as part of the revolution to bring their ideas to the foreground. And our guest today is Michael Laine. I've known Michael many, many years, and he is one of those people. He's been in this field for a while. He's been slogging it out. And part of what I have noticed is that some people fly in and fly back out, and because it's too hard or things are taking too long. There are other people who fly in and you wish they would fly back out because, well, they're just a little bit crazy. But then there are people who roll into this field and they have a good idea, and maybe it's too early. Maybe the industry hasn't matured to the point where it needs to be. Maybe the cost models or whatever it is aren't where they need to be. And then they stick around and they don't drop the idea, but maybe they modify it. Maybe they dance a little bit with what's going on in the field, and eventually it starts to catch up. I think Michael is one of those people, and his concept of using elevators, which we're going to go through sort of the arc of that story tonight or today, whenever you're listening, really is one of those kind of guys. So, Michael Laine, former Marine vet, thank you for your service, Michael, and attended Boston University a while back. Went through there, International Space University, which I worked with way back in the day. And then basically has been doing the technology game. He actually created one of the very first grocery store shopping experiences. I've heard of those way back in the when times. And since then has been focused in on space elevators. Now, if you don't know anything about space elevators at all, we're going to talk about that. If you saw there was a Star Trek episode where there was a long tower, kind of like a space elevator. We'll chat about that in a minute. And then the Foundation series that's running on Apple. Mm-hmm. The first season, I won't get into it, but there is a space elevator involved. I don't want to do a spoiler. I hate them when people do that to me. So anyway, without me talking any further, I want to introduce Michael Laine of Liftport Incorporated. Hey, Michael, how you doing, man?
Hey, Rick. Always great seeing you. Thanks for having me on your show. Looking forward to this.
Yeah. So, Michael, let's start at the conceptual idea so people understand what we're talking about, right? Because we have a wide range of people paying attention to the show. Tell us, what is a space elevator?
Sure. It's an old idea. It's over 100 years old. But it's something every fifth grader can work on, right? So imagine you have a ball and a string, spinning it over your head. The string in the middle stays straight. Now imagine expanding that to an Earth-sized system. The Earth is providing rotation. You have a counterweight, a satellite deep out in space with an extraordinarily long, strong string. The mechanics are the same. The string stays straight. And once you've built that, you can climb up and down the string using robots instead of rockets to get to space. And that idea has been around for well over 100 years. Silskovsky, the founder of the rocket equation, came up with the original ideas. It stayed in Russia. Artsutinov did some work on it. And then it kind of moved into the realm of science fiction. Jerome Pearson independently invented it. Important to note, it's actually been invented a few times. So it was originally invented in Russia, but then Jerome Pearson, an American, invented it. He got the attention of Arthur C. Clarke, who, from Space 2001, Space Odyssey 2001, Clarke popularized it in a book called The Fountains of Paradise.
Mm-hmm.
And from that, it stayed in pop culture for 40 years now. It's all over Japan. It's in anime and manga. It's, as an idea, it's the last project Tony Stark works on before he dies. From the Avengers, yeah, in the comics, it's the last project he works on before he dies. So it's been around in pop culture in a lot of different ways. Yes, you mentioned the Foundation series on Amazon. Just a few weeks ago, there's a movie called Wandering Earth from China that was quite good.
Yes.
Great special effects, fantastic special effects. I leaned over to my friend. I'm like, "That's not how space elevators work," and he laughed because he's worked with me on
Mm-hmm.
them. So none of those are very good depictions. It's been in South Park. There's an episode with the space elevator in South Park. So it's been in pop culture for a while. But the core idea: ball in the string, spinning it over your head, string in the middle, climbing up and down that string. That the physics of that absolutely work. And so from 2001, 2, and 3, there was the original NASA Institute for Advanced Concepts research team. I was part of that. I was the second guy on the team there. Hats off to my former business partner, Dr. Brad Edwards, for doing some of the original pioneering work. When the space shuttle Columbia crashed, he and I got into a pretty big argument. That's all public record. I'm not throwing him under a bus or anything. And we split. We split the company. He took one path, I took another. So 2003, 4, 5, 6, and 7, that was the beginnings of Liftport. And we focused on two areas really: the mechanical processes of climbing. So we had high altitude balloons tethered to the ground with robots climbing back and forth, and we worked on the materials, carbon nanotubes for the super strong material for the string. Our materials work was primitive. That's a generous way of putting it. Truly, it was pretty awful. No slam to my team. They did the best they could, but 20 years later, and the world still doesn't have that string. So our paltry $200,000-$300,000 that we invested into nanotech materials, it's a drop in the bucket to the billions of dollars that have been invested with still no solution. Now, in fairness, there's a group out in the UK that looks really promising. So they do have some strings that look really attractive. But it's not just about the strength. That's what everybody looks at. But it's length, strength, alignment, chirality, which is the twist of the string, mass production, and functionalization. So there's 6 breakthroughs that need to happen. The folks in the UK look like they've got 1 or 2 of them. So hats off to them for making the effort. But those early days, 2003, 4, 5, 6, and 7 of Liftport, we got pretty good at the mechanical processes of climbing. And that's when you and I met, Rick, was those early days at the Space Frontier Foundation.
Right.
We climbed as high as a mile. We had a set of balloons tethered to the ground with robots climbing up to a mile high. We start out by building robots in my best friend's garage, and then we built them out of Legos for a while, and then little by little we got access. Microsoft Research was terrific. They gave us access to their laboratory equipment. So then we started being able to build it with Uh, 3D printing wasn't really a thing back then, so we were doing a lot of laser cutting, and we made more and more and more sophisticated robots. Our pinnacle was a mile high in altitude for one set of experiments, and a different set of experiments that lasted for 60 days. So we call that high altitude, long endurance, HAIL.
Hmm.
And we were just at the point where we were going to merge those two techs when the whole world caught on fire and our company closed. So
Mm.
that was a part of the financial crisis. We closed in 2007 as a part of a real estate collapse. So my personal wealth came from real estate, and so when that happened, the the Liftport at the time was not 100%, but 90%, 95% self-funded. So when my
Hmm.
real estate assets evaporated, the company closed very quickly. So those are rough days. But that was the original version of Liftport and the original focus on building Earth, an elevator for the Earth.
Yeah, and look, here's what's important. And again, anybody who's listened to the show knows that um, failures and being too early and undeveloped technologies and outside forces are a huge part of what we in sort of the visionary part of this revolution have to deal with. It just that's the way it is. I mean, my list of failures is probably even longer than yours, and a little more spectacular here and there with the asteroids and the spacesuits and the whatever. But look, that's what we do,
Yep.
And as I like to say, and others have said, it's not how you fall down; it's how often you get up and how you get up. But let's, for just a second, talk about the tech of this. One of the interesting things I've always that kind of blew my mind when I first learned about it was that it's not so much that yes, you are swinging the ball and all of that, but the way you build it is you go out into space where the ball is
Right.
that's not connected yet to the Earth. It's just on orbit,
Yep.
and it would be geostationary, which is why the fountains of paradise occur near the equator.
Mhm.
And Arthur Clarke came up with this idea of geostationary satellites, and that is that at the equator, an object that is far enough out, just precisely the right distance out, will stay above the point of the Earth where it's put and orbit around the Earth there, which is where your direct TV satellites,
Mhm.
these kinds of satellites are. They are spinning, but they are matching the speed of the rotation of the Earth at the equator precisely. And that's how you do it. Now, for a space elevator, the way you do this, from what I understand, correct me, is
Yep.
you start dropping the string towards the Earth and you start releasing a string out the other side to balance it exactly at the
Exactly right.
same time. They're both building out, and gradually you're dropping the string down, down, down to the ground, and then you connect. Correct?
Exactly right. Yep. Yep.
Yeah.
You're going to connect it more than likely out in the ocean. We really like
Okay.
the Pacific Ocean. Directly south of San Diego, directly west of Quito, Ecuador, there's a nice, calm, dull spot beyond the Galapagos, but that general area. Um, NOAA over decades has registered very few storms there. So where you place it is really important.
Hmm.
There are some spots in the Indian Ocean and north of Australia that also look interesting. We During the original NASA NIAC days, we really discounted putting it on land for a couple different reasons. One, lightning strikes the land more than it strikes the ocean, so that's
Mm.
important. But also, volcanoes and fault lines and politically stable nations on the equator are surprisingly rare. So,
Hmm.
So the oceans really ultimately kind of looked like the best place, and so that would be the what we refer to as the lift port is the station on the ground
Hmm.
at the ocean, um, and then there's a space station at the geo point, exactly like you just described, and then further out, um, the longer you make the string, the smaller the counterweight could be. So in the Fountains of Paradise, they were going to use a giant captured asteroid. Okay, they were going to capture a space rock, and I'm not telling you something you don't know, Rick. Capturing a space rock is hard.
Hmm.
And it's also not a good day for the dinosaurs if you get it wrong. So rather than have, and this is one of Edwards's big breakthroughs, is rather than have um, an enormous captured asteroid, we could just use the fairing and the equipment that goes into space as the counterweight, just make the string extraordinarily long.
Mm.
And that was a pretty big breakthrough. So long string, counterweight, from the top, a counterweight at the top, a string, a station at the geo point, and then a station down at the bottom, the lift port. Um,
Wow.
and
Now,
the
go ahead.
and all of that, go back in time 20 years ago, that seemed very, very doable. We're in March. Liftport's anniversary is in April 2003. So
Hmm.
that's when Liftport officially started. So we're right at 20 years of the company, um, and it it looked very achievable at the time. Uh, but over time, things have changed also. So I still stand by the physics, and I still stand by that report. Um,
Hmm.
but the world has changed. Rocketry has gotten better. Satellite technology has gotten better. All of this stuff has made um, our pivot, and we'll talk about it in a moment, but our pivot to the lunar elevator more likely, and it's actually made the Earth elevator even more difficult. If it was already difficult, it's even more difficult now.
Hmm.
Um,
Yeah, one of the analogies I used to use was because everybody was like, "Well, we should do it right now." Was that yes, it's a great idea to have a bridge between two places. In this case, it would be the Earth and space,
mhm.
right? And by the way, that's the beauty of the elevator. You don't have to use
Yeah,
rockets once you have
right.
one. You just like
Yeah,
up and down, up and
up
down,
and
up and
down.
down. Punch the floor, and the nice person standing there with the hat on. No, I'm sorry, that's an Earth elevator.
Right,
But anyway, so the thing is that you have to get to a level that economically justifies the bridge. And right
right,
now, I mean, at first, like there's an island out there and you're thinking, hey, I want to go to that island. So you got to paddle on a log, and then eventually you get a boat. And then pretty soon you get a ferry. And then enough is going on both ends to
right.
justify building the bridge because a bridge is a pretty expensive, massive industrial undertaking. And we are kind of at I don't know, somewhere between the log and the ferry. We're getting to the ferry,
Right.
right? And hopefully with Starship, all kinds of great stuff will start happening. But the key is there has to be enough economic business going on
Right.
in that island, or in this case, the rest of the universe,
Yeah.
to justify the cost. And this would be like one of the most expensive things ever built, right?
No, 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 no. Now everybody always says
Oh,
that, but it's
okay.
definitely not.
Straighten this
Um,
out.
uh, our budget back in 2003, 4, 5, 6, and 7, we were anticipating it was about a $10 billion project. Well, that's a lot
Wow.
of money, but 10 billion is not the most expensive project ever built. 10,
No.
10 billion is, a city or a state could finance that. I live in Seattle. There's 5 different $1 billion projects going on right now, 5 different ones in our
Right.
city alone. So now, fast forward, it's been 20 years, inflation, inflation, inflation. Sure, the cost of the Earth elevator. Uh, Again, I haven't worked on it in more than 12 years, But my argument, my guess would be a solid 20-25 billion. Still expensive, but but doable if the rest of the system worked, if the rest of the system was available. So um, it's an infrastructure project, and you're right to look at as a bridge. Um, there was $7 billion, $7 billion of private equity, private capital that went into the space community last year.
Mm-hmm.
Maybe more than that if you start adding up all the governmental programs, but I'm just talking the private side. There's definitely the capital to build infrastructure like this. Now, I question, with all of the satellites up there, when I started, there were 400 satellites. What did we launch last year? 1,500 satellites.
Mm.
There's nearly 8,000 up there right now. So the idea of having a ribbon on a platform moving back and forth to dodge all of those low Earth objects, low Earth orbit objects, that looks pretty hard to me. That looks pretty hard to me.
Well,
Uh,
let's get into that a little more here in a minute. We're going to take a break.
okay.
We've kind of gone a little bit long, but that's fine. We're having fun. Um, so, gang, you are listening to iRock Space Radio, part of the iHeart Radio Network. My name is Rick Tumlinson, and you are listening to the Space Revolution. Our guest today is Michael Laine, and we'll be right back. Hey there, spacers. Welcome back. iRock Space Radio, Rick Tumlinson, and you're listening to the Space Revolution. Our guest today is Michael Laine, and we are having a fascinating conversation about space elevators. So, Michael, we were talking about the fact, and it's interesting what you were just saying. Wasn't thinking about that. The fact that, and this is something that's starting to show up in a lot of conversations about orbit and space right now. So much stuff.
So much stuff.
So much stuff. It's almost like we're building a cage around ourselves, right? I mean, unless you can dodge left, dodge right, in and out and everything, you know, I mean, poor Sandra Bullock, right? I mean, you know, we gotta protect Sandra Bullock
Right.
and George Clooney. I mean, my God. So
We'll have a whole new poster series that says "Bring them home" instead of "Bring him home" from.
yeah, there you go. So seriously though, yeah. So space elevators, and you don't want to be moving those things around very much because, frankly, anytime you move a long string around, little resonating, vibrating, yeah, isn't that how pianos and guitars work? I
Yeah,
mean,
yeah, yeah,
seriously, right?
exactly, right. So it's important to note that the Earth elevator is always in motion. If everything was completely gone, if there's nothing up there at all, you're on the ship. The ship is going up and down with wave action, tidal and normal, right?
Mm.
And it also has to do station keeping because there's a current where we want to place it. There's a current there. So there's always the thrum of the engines, right?
Mm.
There's wind at different altitudes going different directions and different speeds, right? So that sets up vibration. As the robot, we call it a lifter, as the lifter is climbing up the string, it acts as if it's not, but it acts as if it's two separate strings, the one that's on the bottom and the one that's on the top. The shorter one has a faster frequency vibration, right? And so as the string, if you put your finger on the guitar string and move it up, it changes pitch, right?
Right.
The same thing is happening. So there's a quick vibration on the bottom string and a slow vibration. So all that's happening, and that's kind of part of the natural system.
Right.
And then now you've got, again, there were 400 satellites when I started. There's nearly 8,000 now. That's active satellites. Let's not forget all about the debris that's up there, right?
Mm-hmm.
And here's where you start getting into law and international policy and rights of way. all of those assets, billions of dollars worth of hardware, many billions of dollars worth of revenue, 200, $300 billion worth of revenue, they all have rights of way. So the elevator has to move and dodge. Its cosmic dodgeball has to, and so you have this ship at the ocean. I don't see that happening. I just don't. And I saw this about 2008. I started really looking, like Liftport had officially crashed and closed. I wanted to figure out what was next. I went out to International Space University, and it was kind of a soul searching litmus test for me. Do I stay in space, or do I get back into investment management? And I wanted to stay in space. And so, you talked about, the people who stick. Well, that was my moment to bail. If I was ever going to bail, is when I'm making front page news for failure, right? And so I'm looking at this stuff and I'm thinking, gosh, now we didn't have as much orbital traffic then in 2008 as we do now, but you could kind of see it happening. And so all of those companies, all of those countries that have those 8,000 assets, they all have claims to that rights of way. And so the elevator's got to dodge that. And I don't know how you do that. Now, hats off to Dr. Pete Swan. He did a survey, I think it was 2011 or so, that was looking at orbital debris and said, okay, we're going to build the elevator in such a way that it can withstand an impact. Okay, fine. So maybe that's true. I have some doubts about that. And that report came out before Russia did their second anti-satellite test, and India did their first anti-satellite test, and China did their first anti-satellite test. So when the data was complete 10 years ago, it was true. I don't think there's been an update to that report, so I don't know if it's still accurate or not. So there's an orbital debris problem of debris. There's an orbital traffic problem of current financially producing valuable assets. And then the third one is the reason for building the elevator in the first place. We were excited that we could bring the price down to $100 a pound, $200 a pound. Well, if SpaceX achieves that with Starship, you're going to also have follow-ons with Blue Origin and Relativity and Rocket Lab and all of the other companies that are trying to mimic that, right? How do you pay for a 10 or $20 billion asset at $100 a pound? That's a lot of cargo you got to move. And we were really excited that, Liftport was, our baseline 20 years ago was we were going to lift 50 tons a week. Sorry. 100. We were going to lift 100. I've got something wrong. I'm saying something wrong. Anyway, it doesn't. It was a bunch. It was a bunch. It was 20-year ago math. But it was a lot. It was a lot. And so I don't know if you've got the economic value there to do it. So
plus
I think
you're also, go ahead.
Those core problems. I think so. You still don't have the string, right? The string still is elusive. It will be solved. The physics of this work, the materials will eventually be solved. I'm very confident of that.
Right.
But the other problems, I don't know if there's a solution to them.
Right. And you have the scale of the Earth, which means the size of it has to be so much bigger.
Right.
And you're dealing with atmosphere.
Yep.
Which brings us to the moon.
To the moon. Yep.
Right. Great view, no atmosphere. So
great.
You pivoted.
Yeah.
And started talking about the moon. That, frankly, because I was skeptical, I have to admit, I loved it all the time. I was always skeptical. But then when I heard that you were starting to focus on the moon, that's when I started to get excited, because there's a case there, and I'm going to let you explain that now. So a lunar elevator, why does that work Talk about it.
Well, so first of all, I want to go back to your analogy of a bridge.
Mm-hmm.
Um, the world is going to the moon, right?
Mm-hmm.
I'm not sure how to categorize this, but there's something in the neighborhood of 200 missions going to the moon. Um, that's not 200 individual rockets. That's 200 different programs that are going to hitch a ride somewhere or another. Um, that's a lot of activity, and it's going to increase. And I would argue we're probably also in a space race with China officially
Mm-hmm.
now.
Absolutely.
So I think that puts some energy into it. So the moon as a target, as a destination, has probably never had this much activity, even during the heyday of the Apollo program.
Mm-hmm.
Um, but we weren't looking at that then. This is 2008, 9, and 10 when we were trying to understand if we could. So, some personal stuff there. I
Mm-hmm.
still wanted to work on the Earth elevator, and I thought the fastest path to do that was maybe a skyhook, which is kind of a rotating elevator
We're
version.
going to hit that in a minute, but go ahead.
We're not. It's a terrible idea. We're going to skip it.
Okay. Okay. Fine. All
um,
right.
so we looked at a lot of different ways of doing this, and we settled on the lunar elevator with the goal that if we build the lunar elevator, we can prove the Earth elevator.
Mm-hmm.
Turns out over time, 2008, 9, 10, that was the plan. And then 11, 12, 13, it was more like, maybe that Earth elevator is not going to work the way we think it is. And we start seeing all this other disruption in the industry. And then we start really looking at the moon, and we realize that um, a lunar elevator is getting easier every single day. Right? There's
Mm-hmm.
more activity going to the moon. There's more rocketry. There's better communications. There's better robotics. There's better materials. And here's the thing, because the moon is much smaller, we don't have to invent another super material. The materials that we need for the string already currently exist. There's at least
Ah.
14 candidate materials already available at mass producible scales. It's purchase order technology,
Mm.
right? You want to talk about commercial off the shelf? Yeah. We need to write a purchase order. That's it. That's what we got. We've already
Mm.
done some investigation on that. You don't have the atmosphere. You don't have the strength requirements. But along the way, again, this is kind of an evolutionary project. When we were looking at this originally, no one else was looking at the moon. Nobody was taking it seriously. This is the early days of the Obama administration. They didn't look at the moon. They started looking at asteroids. Cool.
Mm-hmm.
But we're like, hey, moon, moon, moon. It's cool, right? It's cool. Just trust us, right? We were getting no traction at all. The real breakthrough, what kind of gave us some political cover, and I have to use my words very carefully here, was we got the attention of Dr. Joel Mosier. He was at the time the chief scientist of Air Force Space Command. Now,
Mm-hmm.
he has since been promoted to the chief scientist of U.S. Space Force. But he brought us out to Colorado Springs to do an evaluation. They call it Tech Rats. I forget what it stands for, but it's a technical readiness assessment.
Mm-hmm.
And there's 5 of us and there's 12 of them, and the 12 include Aerospace Corporation, Air Force Academy, 2 spooks that won't name or give their affiliations. Um, pretty interesting crowd. Pretty interesting
Mm.
crowd. And we showed them our work, and they were pretty surprised. Now, I have to be really careful to never say words like endorsement, because that's not
Of
his
course.
role, that's not his job, and he will get in trouble and I will get in trouble. So that's not what it was, but it was an evaluation, and we provided some really surprising findings to him. And one of the things was On the Earth, an Earth elevator, it's all about getting off of the Earth. When we first looked at the moon, and the mechanics are a little bit different. We'll talk about them in a minute. When we first looked at the moon and the lunar elevator, it was about getting onto the moon. Soft landing cargo onto the surface is really challenging. It's the reason we go back to Mars all the time, because there's an atmosphere to slow us down and do aerobraking. It's hard to land on the moon with any sort of precision, at least up till recently. So we were all focused on soft landing. Turns out soft landing is useful and important. We're going to the wrong spot. We're going to the equator, which nobody wants to go to, right? So that's not really helpful. What turns out is to be maybe the most useful use case is a Lagrange point station that could be as large as you want to build it. So let's talk about how we construct this thing.
Hang on.
Yep.
We're going to come back and talk about that.
Right.
All right. I got too carried away in that first section. We went a little bit long. I'm going to catch you this time at this moment because I'm enthralled. This is cool.
Gotcha.
All right. You are listening to the Space Revolution. My name is Rick Tumlinson. Our guest is Michael Laine. We are talking about space elevators, moon elevators, all kinds of elevators. Well, we're not talking about grain elevator. Completely different topic. That's a different show. Anyway, just kidding. All right, we will be right back. All right, spacers, come on into the elevator. Press the 13th floor. We're going to the moon. I have Michael Laine with me. We're talking about space elevators. This is iRock Space Radio. We're part of the iHeartRadio network. Okay, so Michael, we're on the moon now. We're looking at elevators. Yep. We've decided that the Earth, too many problems, too many hassles. You've talked to Dr. Moser, who's now Chief Scientist of Space Force, good friend of both of ours. Brilliant, wonderful guy. You've got their attention, and you're starting to zero in now on how would we do this and why and where we would do this on the moon. So tell us about it.
So we talked earlier about how we construct the Earth elevator. We get out into space, we drop a string down to the surface of the Earth, we attach it to an anchor point out in the ocean, and then extend the string out. And the longer the string, the smaller the counterweight. All of the things that we learned from that, working on the Earth elevator, first under NASA NIAC and then our own research, all of those things we could apply to the lunar elevator. So the construction is somewhat similar, but the difference is for the Earth system, we refer to that as a centripetal elevator, right? Spinning. The moon doesn't spin nearly fast enough. You'd have to have a crazy long string. Instead, we refer to this as a gravitational elevator because the front side of the moon is locked to the Earth, tidally locked to the Earth. We only see the front side of it. There is no such thing as a dark side, but that's a different show. We see this. We see the front side. We drop a string down to the surface of the moon, pull it through the Lagrange point. We'll come back to the Lagrange point in a moment. We pull it through the Lagrange point back towards the Earth, and the string is long enough and the counterweight is large enough that the Earth's gravity gently tugs on that string and the counterweight, and that's what keeps the string straight. Does that make sense?
Wow. Yeah, so basically, we're looking at the moon.
Yep.
Okay. Sea of tranquility, all that stuff going on, right? And basically, dead center, you're running your elevator towards the Earth.
Correct.
Right? And dead center towards the center of the Earth.
Yep.
As seen from the moon.
Yep.
And that pull keeps it straight.
Exactly.
Correct?
Right. 100%.
Okay, great. Gotcha.
Yep.
Oh, and I should explain Lagrange points.
Yep.
You hear L points, L5, L whatever. Those are points in space that are sort of like neutral zones. They're eddies. There are places where the gravitational field of two bodies like the Earth and the Moon or the Earth and the Sun create these interesting little points where there's sort of a cancellation effect that goes on. And there's five of them for every two bodies. There's one between the Earth and the Moon, one on the far side of the Earth and the Moon, one to the right of the Moon, one to the left of the Moon, and then one on the far side of the Earth. And they're all kind of neutral spots. Mm-hmm. And they give you the ability to use a lot less energy because they are like eddies. You know what an eddy is when you're looking at like a stream and you see things that are little leaves that are just kind of caught in one place. The stream's flowing, but these guys are caught in one place. So imagine gravity doing that. And now you've got these little places. So that's what an L point is. And there's one precisely between the Earth and the Moon when you look straight at the face of the Moon from the Earth. That's where we're going. Go ahead, Michael.
Exactly right. So the Earth, because it's so much larger than the Moon, that gravitationally cancellation point, the Lagrange point, and we're using EML1, Earth Moon Lagrange 1 specifically. Mm-hmm. It's way closer to the Moon. If it's roughly 285,000 kilometers between here and there, 285,000 miles between here and there. I do that all the time. I'm gonna crash something someday because I get my conversions wrong. I do it. All
NASA
the time.
Already did that once, but go ahead.
Embarrassing. Yeah, ESA crashed into the Mars for that thing. So it's closer to about 40,000 miles from the surface of the Moon. So it's definitely weighted that side, right? Mm-hmm. But the gravity of the Earth and the gravity of the Moon kind of cancel each other. There's still gravity, right? But if you're Sandra Bullock and you fall, if you're on the left-hand side, you're gonna fall to the Earth. If you're on the right-hand side, you're gonna fall to the Moon, right? Mm-hmm. That's it. That is what's going to happen. If you don't have any other excess energy in the system, you're going to fall. So what turns out, one of the things that surprised the chief scientists of Space Force is that, look, we are the fort at the top of two hills, right? In military parlance, you want to be at the fort at the top of the hill. But the Lagrange 1 is the fort at the top of both the Earth and the Moon's hill. That's a pretty good strategic place to be. And that really got people's attention. That was pretty exciting. And what we realized was by having a string punched into the surface of the Moon, you could build, whereas when you were describing the Lagrange points a minute ago, 1, 2, and 3 are unstable because of the perturbations of the Moon. The wiggle of the Moon makes 1, 2, and 3 unstable. 4 and 5 are relatively stable. Mm-hmm. But by having a string attached to the Moon, that stabilizes L1. You can build anything you want there as big as you want. So when we build the Enterprise, we're going to build it from an L1 station, from the lift port station at L1. That is the most valuable real estate in the solar system. I know that you think Phobos and Deimos are pretty cool. I get you. But L1, you got all of the brain cells over on this side of the equation and all of the resources on the other side of the equation. And that bridge, that's a pretty good bridge to have.
You're winning me over. That's yeah, and that's a whole separate argument regarding Deimos and being at the top of the hill and stuff. But what you're talking about, in a sense, and I like the fact you use the Star Trek analogy, it is a deep water port.
Deep water port, exactly right.
You're out in the ocean of space, far enough to be definitely out there. Access to the Moon is simple. Access to the Earth is more simple.
Yep.
Keep going then. So that's where you want to build.
You want to build everything there. You want to build everything there. That becomes a gas station, so our friends over at OrbitFab can have a site. It's the place where you're going to do manufacturing for space-based solar power. You're going to pull the resources off the moon. You're going to ship these super fragile electronics up from Earth. You're going to assemble them together and then ship that solar panel back to Seattle and power
Mm-hmm.
Seattle with clean, green, limitless energy. It's going to be storage. It's going to be command and control. It's going to be operations. It can be an arbitrarily large space station.
Mm-hmm.
There's, you know, I don't care how much Elysium money you have. If you're going to build an Elysium class space station around the Earth, you have to keep fueling it every day, right?
Mm-hmm.
Um,
Now, hang on.
um,
I have to clarify. We are not sending all the rich people into space and keeping the poor people on Earth. All right.
very
Let's
important,
just
very
talking
important.
about an example, just an example.
Just an
But yeah,
example.
go ahead.
Well, no, but it's important, right? That there's about a half a dozen space station companies in development.
Mm-hmm.
There's at least five that have a $500 million in their checking account.
Yep.
Five companies with a $500 million working on space stations. Cool. But all they're talking about is like Lego parts, and cool for them. I don't want to like disparage them. I'm super excited that they're going to exist. But there's a functional limit to how big they can build those things. And
Yeah.
at the Lagrange point, stabilized by a string, there is no functional limit to how big you can make that thing.
Right.
So I think it's going to be really interesting. That's our future at Liftport, is to build out the combination of the transportation system down to the surface of the moon. And you nailed it a minute ago when you said it's that, like, if you were to draw a straight line from the center of mass of the Earth to the center of mass of the moon, that's the line the string follows, which means the point that we're going to land is Sinus Medae. It's the 0, 0 lat long point on the moon. It's called Sinus Medae.
Mm.
That's a long ways from Shackleton Crater. There's no simple, easy path. So everybody in the world that's trying to go to the moon right now, yeah, okay, I'm not going to say they're going to the wrong spot, but they're going to the wrong spot in relation to what we are doing.
Right.
So,
So let's talk about that for just a second so people understand. We've talked before a little bit about the fact that you have the shadowed craters at the poles of the moon. The bottoms of those craters, where sunlight has basically never
never.
hit, means that there is ice there. And I worked on the Lunar Prospector years and years ago to try and check that out. And so there's no there. It's pretty dry where we're talking about putting this thing. However, if I can go there with you, Mike, what you're looking at is two phases of lunar development. Phase one, where we're using what in 200 years will be old school rockets flying from the Earth, right? And they're refueling and going back and forth, and they're using the water to create propellant and everything they need from the lunar poles. Phase two, coming back to that city where you need the bridge, by the way. Phase two is you're getting to the point where you've got so much going on that now you can build the lunar lift port.
Yep.
And at that point, then things start to shift. But that presumes, of course, there's a lot already going on at that point. I also have one other interesting point. I've had Phil Metzger on. Phil is big, big, big on making sure that rockets coming and going from the moon are not blowing moon dust, which I call razor blade talcum powder, all over the place. That's going to be a huge problem. It's
It
a
is.
big, big, big problem. And the more you're doing on the moon, the more this stuff you're throwing up. And again, it's not like dirt or it's not like dust. It's like microscopic razor blades that get everywhere.
Yeah.
It's going to be a killer. It's going to get in your lungs because you're not going to be able to get rid of it. It's going to get
Yeah,
in
I
all the
want to
joints. It's
stress
terrible.
you're not being sarcastic or figurative here. It's going to kill people.
Yes,
Yeah.
absolutely. So you need to keep it pinned down. Now, in the early days, what Phil is talking about is like concrete or glass or whatever over the landing pads. Great, great idea. But eventually that's going to become a problem too. And so what you're talking about though doesn't do that.
Nope.
It's passive. It doesn't kick anything up. It's not like rockets landing and billowing out of this
Nope.
deadly clouds, right?
Nope.
So it's a whole different thing, but it's in a different place.
Yep.
So what's the status now? Where do you think it's going to go? And we'll wrap up this section with that comment.
We're going to go where we need to go. Now, we've looked at the math, and we could, in fact, build a string and point it at the Lagrange point at Shackleton. We could. The math is there. It is complicated, more difficult, and frankly, we don't think it's worth the effort for the chance of failures. So we're not going to be doing it. So yeah, we're going to go to Science Midday. There's stuff at Science Midday. We've been looking pretty close there. We think there might be a keyhole lava cave somewhere nearby. Maybe. We don't know that for sure. We think that there might be some other interesting stuff. There definitely are some minerals in the area. So we'll work with whomever wants to go there. Yeah, we know we're going to slightly the wrong place, but we think that the combination of both the Lagrange point station and the center point of Science Midday, that becomes pretty valuable to us.
Yeah. So to wrap this up, basically at that point too, you're presuming there's enough stuff going on in the island,
yeah,
to start building the bridge.
Yeah, there's going to be so much activity in this whole cislunar econosphere. It's already north of $400 billion. It's going to be $1 trillion not too long from now. If space was its own economy, it would be in a top 20 nation status. And that's a cislunar econosphere. So we'll be a central part to that.
Great. All right, we'll come back in a minute. Again, you're listening to iRock Space Radio. My name is Rick Tumlinson. This is the Space Revolution. Our guest is Michael Laine of Liftport, and we are talking about elevators in space. Actually, lunar elevators. Okay, spacers, we're on the moon, and you're about to take an elevator into space. It's Rick Tumlinson. You're listening to iRock Space Radio. This is the Space Revolution. Our guest is Michael Laine. By the way, you can follow me on @RocketRick or LinkedIn or Facebook. Can't follow me on Twitter. Could follow me on Instagram. And there's probably about 25 other places you cannot follow me. So find me in those places. Don't pay attention to my stuff when I get crazy with NASA, because I love NASA. But you can hear a lot about these different things, and we will comment on them. I'll be commenting on them in the future. Our guest, Michael Laine, we're having a fascinating conversation with space elevators, moon elevators. I want to see you succeed. Let's wrap this up real quick, because I want to get to a couple of super important questions. But what do you think the future is? Is there funding? Is somebody going to support this?
Yeah. I told you a little bit about our history where 2001, 2, and 3 under NASA, 4, 5, 6, and 7 privately funded. We've been privately funded for, I guess we restarted in 2017. So the current version of Liftport is started in 2017. It's privately funded, not well funded. I'll be really honest about that. But we've got 6 people on our team now. So, we're covering our bills. We're not growing the way we'd like to. And in 2020, we almost went out of business. I mean, just call it exactly what it was. If we had been doing biotech research, maybe it would have been easy to get funding, but elevator on the moon research, there was no funding for us. So we almost closed. And as a result of just being resourceful and aggressive and pivoting as needed, we wound up doing a bunch of online conferences. When the world needed space conferences, we were the folks handling that. So we handled 27 conferences over about the last 3 years. Mars Society, Moon Society. We're going to do some stuff for the Space Frontier Foundation coming up soon. Probably about International Space University, Chief Scientist of U.S. Space Force. We have about 7 or 8 clients, and those were the folks that kind of kept us in business while the world was on fire. And
Hmm.
so now we're in this spot where, in fact, we grew. We went from 3 people to 6 people because we are so good at putting on these virtual conferences for folks. Um, as the world has shifted again, um, we're now starting to do a bunch of. We're not doing as many virtual conferences because there are people that don't want to go to virtual conferences anymore. So I get that. So we're now doing a bunch of podcasts. We're doing podcasts as a service for the other companies that we were talking about earlier, the
Hmm.
nonprofits who we were talking about, and that's kind of kept things going. That's kept the lights on. But we're now in this spot where I say this to my team all the time. I love doing this media stuff, but I want to get back to the core work of working
Yeah,
on the elevator.
seriously.
Yeah, yeah, yeah. So we just submitted a proposal a couple days ago for something. We've got some other proposals we're putting together. This is going to be a combination of private capital and government funds to work on the pieces of it, and we'll stitch the rest of the pieces together.
It
So,
seems like this is. I mean, look, and not to cut you off, but I mean, the different kinds of jobs I've done. I did video production for a
yeah,
while, things like
right,
that,
yep,
because these things didn't pay. But I think your time right now, give you a little advice on air, is go for it now.
yep,
Get your IP, get some patents onto
yep,
your ideas so you have value. Because again, we're moving into that moment. We're moving into the moment. And whether it's SpaceX or the other companies, somebody's going to break the Earth to space transportation thing open
it is.
in the next year or two.
Yep,
And even the fact that even if we haven't, people are going to be talking about it. Investors are going to be paying attention and they're going to
yep,
start moving this direction. I'll tell you that as a venture capitalist.
yep.
They're coming. Get ready. Get out there, Michael. You've got what it takes. You've got the team. Do it now.
Thank you.
So let me hit you with some serious
Well,
questions.
let
Go
me
ahead.
add
Come
one
on
thing
back.
in there,
Mm-hmm.
right? So we talked about the Earth elevator. We did a lot of comparisons. I want to put something in your head that maybe you're
Mm-hmm.
not aware of. If the Earth elevator is a $20 billion question mark,
Mm-hmm.
the lunar elevator is 800 million or less.
Okay.
800 million or less. And we have what we've done in the last 3 years when we couldn't do a lot of the other core work was, you know, we've got a new business that solves a research problem for $1
Mm-hmm.
million dollars, and that research problem, we learn what we need to learn, and we have a new revenue stream. We have another level at the 5 million where we learn something we need to learn. We have created a new business and created a new revenue stream. And we have something at the $25 million level where we learn something we need to learn, create a new business, create a new revenue stream. So that's how we expect to grow this thing before we go out and try to do an $800 million unrealistic raise. We're going to do 3 raises that are more bite sized, prove that we can do what we can do, learn what we need to learn, generate revenues and IP along the way so that we can show investors that this incubator with a purpose, which is kind of how we identify, that we can do the things that we say that we can do, roll out some businesses, roll out some IP, roll out
Mm-hmm.
experiments, prove the pieces that need to go into building the elevator. So that's our
Good.
plan. Yeah.
Good.
Yeah.
Stay on track. And as a VC, we always look at, okay, these guys are resourceful. They were doing this other thing, but then you got to get back to your true north, or in this
Yep.
case, you got to get the elevator pointed
Yep.
at the Lagrange
Align.
point, right?
Yep. Yep.
So go for it. And I think you may find that things are going to move faster than they have before. I really believe it's coming. Um,
Awesome.
and
That's
those who
great
are
to
in
hear.
position to take advantage of it are going to be the winners of the day. And it's going to be phase one, phase two, phase three.
Yep.
Phase one
Yep.
is going to be people that are going to take advantage of starships going to and from orbit.
Mhm.
Going to and from the moon will be phase two. And then what you do on the moon or between the moon and orbit, I'm sorry, between the moon and the earth, that's going to be phase three. And it's coming, it's going to come faster. I think we're at that moment, where the roller coaster is at the top. and you hear click, click, click,
Click,
and
click.
then yeah. All right, enough gravity jokes. So, Michael, tradition, serious stuff. You're cruising over the moon. You know what? You're shooting up the elevator. Moon's down below you,
Right. Yep.
receding in the distance. Earth's getting closer. What would you be listening to, my friend?
So many. Fly Me to the Moon is one of my favorites, so
Hmm.
that would definitely be it. Um,
Or Fly Me from the Moon. But never
like
mind. Go ahead.
credit to Aerosmith, Love in an Elevator for sure. That's definitely on the soundtrack.
Perfect. I like it. Mm-hmm.
um, those are the ones that are going to be, you know,
Okay.
I love Rocket Man. I know that might be like a little off brand, but it's kind of the right thing. So
I'm
um,
gonna go with Love in an Elevator,
yeah,
because nobody else is gonna pick that one,
yeah,
So you
no,
got it.
love
You own the Love in an Elevator space of space, so that's good.
Aerosmith went to NASA. They went on a tour maybe 12, 15 years ago. I don't know how they did a tour of NASA, but they did. And they asked about the space elevator. I've got the clip for it. It's pretty epic.
Well, maybe they'll
Um,
hear this interview because I know we have the license, so I wouldn't be surprised if that song pops up before it does, right?
awesome, awesome.
So yeah, we have a unlimited license. So anyway, second question: favorite science fiction book?
Um, I'm supposed to like Clark because of elevator stuff. Clark was a late love of mine. I didn't get
Mhm.
into Clark until long after, and Heinlein had me in the beginning. So Moon
Of
is a Harsh
course.
Mistress, Starship Troopers, Stranger in a Strange Land, but also all of his like weirdo, not quite like normal stuff. I love Friday. I've read Friday a bunch. I've read uh, Job. Yeah, he's got some great stuff that's not as famous that's also equally brilliant. So
And completely
time
controversial, but
time
good
enough for
stuff.
love. Yeah. He was breaking boundaries a long time ago. Maybe not male female roles,
Hmm.
but like group families, polyamory, like he,
Hmm.
yeah, pretty controversial guy, you know, for writing that stuff in the 70s when he was doing it, 80s when he
Yeah,
was doing
strong characters,
it. Yeah.
but really cool. Anyway, so favorite movie, TV show?
I'm a big movie nerd, so there's too many of those. Um, I don't watch a lot of TV, but Firefly's got to be up there.
Hmm.
I didn't love Expanse the way everybody else did. I know you know them. I know some of them. Great, cool. It was never my show. It was never my show.
Hmm.
Star Trek and Star Wars for sure. All the franchises. I'm super bored with Marvel. The whole Marvel universe. I'm bored with now.
Yeah, yeah.
Uh, but
See,
I
here's
love.
the thing. Here's the thing about Marvel Universe. Just since you
Hmm?
touched on it, I don't. I get bored of superhuman people doing things. What I get excited about is people doing superhuman things,
Yeah,
like space elevators.
yeah.
Okay,
Thanks.
go ahead.
Yeah. I do. I watch a lot of movies, so pop culture stuff. I like stories about humans, even bad humans. So
Hmm.
Schindler's List still makes me cry. Private Saving Private Ryan still makes me cry. Like some of those movies are just epic and awesome, and they're all as goofy as it is. I like Forrest Gump. Like those like stories about people doing things. You just said it actually.
Hmm.
People doing superhuman things. I guess
Hmm.
all three of those stories are people doing superhuman things.
Great.
I
And then,
shout
mhm.
out to Wandering Earth. So there's two now. There's one on Netflix that came out about 4 years ago. It's adequate, but the one that's in the theaters now, it's probably left unless you're in a big city. That's a prequel. Definitely watch that one first and then watch the one on Netflix. It's a crazy story. And I leaned over to my friend. I'm like, that's not how gravity works, right? Like, there's a
Uh huh.
lot of, there's a, It's the best bad science movie ever. Like it's on the same level as The Core and Day After Tomorrow. Like bad science that's fun to watch. It's still a fun short.
Yeah.
Moonfall was like that a couple, maybe 2 years ago. Moonfall was
Mhm.
not how gravity
Terrible
works.
science, but well made.
Right. Yeah. Yeah.
I agree. I agree. And yeah, and the Chinese producers and directors and writers of that, right on. But again, once you accept the premise, right? It's like Walking Dead, right?
Yeah.
Right? Zombies. What?
Yeah.
What?
I love
What?
zombies.
What? They're dead. They have no muscles. How do they move? I don't know. I don't know. But it's really cool, man.
Right. Yeah.
It's a
Yeah.
human story,
Yeah.
and that is the same thing with Wandering Earth. Okay, so here we are. We're wrapping it up. You've told a great tale here of basically persistence.
Hmm.
That you've stayed the course. You've done what you've had to do. You've foraged. You've come up with jobs, tasks, and activities to stay alive. And we have listeners out there who are trying to figure out, how do I do this? How do I get involved? How do I stay involved? What would your advice be to a young person who's out there maybe hearing this and saying, look, I want to get, of any age,
Yeah.
I want to cross the lanes. I want to get into, no pun intended, but I want to get into this field. I want to work in this field. I want to be a part of this movement, this cause, this revolution. What would you say to them to help us wrap up?
Well, first of all, there's room for you. Just know that. Start there. It doesn't matter whether you're an accountant or a dancer or a rocket engineer. There's room for you here in this field. Um, uh, I don't have an engineering background, but I'm surrounded by lots of really smart people. My background's in finance and operations and logistics, and I've tacked on policy and law just for the fun of
Mm-hmm.
it. So the first message is there's room for you regardless of what your skill is. If you're passionate, you will find a place. Second, launch is done. People have done an awful lot in launch. You're not going to you probably are not going to be a change maker in the launch industry. Tugs, space tugs, definitely you can have a giant role there. That's probably the next thing on the immediate horizon. Satellites, different kinds of satellites, probably on the immediate horizon. But focus on the moon. Yeah, okay, Mars is cool and Mars is beckoning, but Mars is still a long ways away in terms of time and money and technology, whereas the moon is right in front of you. So if you're 17 to 37, I would focus on the moon because it's immediate. We're going to have immediate stuff happening on that right now. I think
That's
Mars is
perfect.
still a little further away.
Great. So if you're 38, start focusing on Mars. Everybody else, it's all about the moon. Michael, thank you for a great interview. I really appreciate you giving us your time. Fascinating conversation. I learned a lot myself. I'm starting to look at L1 Earth
Right on.
Earth
Right on.
Mineral
Thank you very
L1.
much. It was super fun. Thanks for having me.
Yeah, thank you, man. And we'll see you around. And ladies and gentlemen, we are done here. My name is Rick Tomlinson, iRock Space Radio, part of the iHeartRadio network. We are out the airlock.